initial idea of the project came from Hopper Ball Track, which is a toy which features unlimited amount of different configurations for the ball to go through a wooden track. It is especially the dynamic aspect of the game we like.
In order to create our own dynamic game, we took a look at already existing ones such as SimCity or the more recent Spore and Little Big Planet. What these games have in common is that they all use a predefined toolbox to allow the players to interact with the game world. And we wanted to try and go in another direction.
To break this trend of having only a limited amount of tools to work with, we wanted to incorporate real-life objects. We wanted this to be a new way to add objects to the game, and by using real-life objects, the player can choose whatever object he has around him, whether he's playing from his own room or from the kitchen or wherever he's situated with the game. This will make the game change according to what objects is around the player and thereby create a whole new dynamic feeling.
We wanted to see if a dynamic game was more engaging than its static counterpart. So with inspiration from the other games we have looked at, we established that we want to look at intellectual engagement. We also want to look at flow, which is a method and a theory by Csikszentmihalyi, and Silent and Zimmerman's meaningful play.
The theory of flow is a way to test if a person is engaged when playing a video game. We wanted to use flow to test whether the players were more engaged in playing our dynamic version than our static version of the game. Some of the aspects of flow is that the players will lose track of time and he will lose sense of awareness of his surroundings.
The term engagement is very complex, and unfortunately we don't have some kind of measuring tool just to put on the subject's head. So by combining different theories, for example O'Brien and Tom's theory of engagement and the flow theory, we wanted to make the measurement of engagement as accurate as possible.
The overall idea behind the level design was to support the idea of change, which is the idea behind the entire product. We tried to design the levels to be more dynamic and free in that we let the player choose his own path through the levels instead of forcing him down a superior predetermined path. And to us, a dynamic game means a free choice for the player, so the level design really tries to incorporate this. The visual design was also meant to support this overall idea of change in the game. And the main color of green is a direct result of this, since green can symbolize both change and renewal. And then we used contrasts to sort of dictate the background color, and also to establish the effects applied to the active objects in the game. So we have contrasts in the form of red versus green color and shiny active objects versus a very matte and flat background.
The game was developed using a 2D physics engine called Box2D. Box2D is an open source engine, and actually it's also the base of quantum physics, which we gained a lot of inspiration from. Using Box2D, we did not have to implement collision detection and gravity, so we could focus on the main aspect of our project, the dynamic aspect.
During the implementation of our game, we ran into a series of challenges. One of these was the implementation of concave objects in Box2D. In its native form, Box2D doesn't support concave objects, so we had to find some sort of workaround for this. Luckily, a beta version of Box2D did have this function, and by merging the code from the two different versions, we were able to adapt it to fit our needs in our game. Another of the challenges that Box2D proved was that it did not allow the user to reposition the objects after they had been initialized the first time. The workaround for this was to reinitialize all the objects every time the simulation ran.
When the user is first presented with the game, he can choose one of two options. He can either start the simulation, which will turn on the gravity and make the ball start rolling, or he can choose to scan in an object. So he can start the scanning by clicking the webcam icon on his toolbar, and then as soon as he's satisfied with the object presented to him on the screen, he'll accept it by clicking the according button on the toolbox again. He can then position the object and rotate the objects that he scanned in order to place them in the area that he thinks will overcome the challenges presented to him, and then try running the simulation again. our test showed indications toward the dynamic game being more engaging than the static version. The dynamic elements of the gameplay was highly based on all the intellectual challenges, such as figuring out what objects to use and determining the right size of the object and how to position them in front of the webcam in order to get them in the game world and stuff like that. So very intellectually based aspects. Generally, we think that it is possible to produce a game that is a dynamic game that is more engaging than a static version of the same game by introducing the methods and uses that we incorporated in this project.